Hey all. I figured because the picture I uploaded wasn't the best quality, I would do a video of going through a 1,2 and 1,4 product problem. And I figured going by step might make it easier to understand. So I've written out the questions that are usually associated with these types of problems, and I've written both of the compounds on both sides because we're going to go through each double bond of the conjugated system. So usually what they'll ask is, one, to provide all of the 1,2 and 1,4 products, and two, to provide the resonance hybrid, and then three, to label the major and minor thermo and kinetic problems. Products, not problems, sorry. So I'm going to start with this double bond over here. And by the way, this HBr ether is a classic hydrohalogenation reaction. So this could have just as been HBr, HCl, HF, or HI. Either of these could have worked instead of the HBr. But anyways, so we have HBr right here. So when this reacts with that double bond, I'm just going to write out like this. We have HBr. This pi bond is going to go back to the bromine, and this is going to reach out and attack this hydrogen, right? So what I'm going to form is this product right here, and this is going to be my 1,2 carbocation intermediate. And I'm sure you've already noticed this carbocation is a tertiary. So now I'm going to react this again to get my actual product. So I have my bromine, which now has a negative because it took that pi bond before, and it's going to attack that carbocation. So what will form is the following. And this is going to be my 1,2 product. And always, well, I guess I should almost always, I should say, the 1,2 product is going to be kinetic, generally speaking, almost always. So now that I have my 1,2 product, I'm going to look at what my 1,4 carbocation would be, right? So from here, I would say resonate and move this pi bond to right here. So I'm going to draw this arrow out real quick. So what you get is this. And this would be, if we were to resonate, so this pi bond came over here, now the positive charge is here. This is going to be a primary allylic, and I should have written allylic here too, sorry. This is going to be my 1,4 carbocation. And now this is going to react with that bromine. And this bromine is going to attack this positive carbon cation. So my 1,4 product will look like this. And since this was my kinetic, my 1,4 product is going to be thermodynamic. So we've gone through everything when we've reacted with this double bond, right? We have what would happen if we react with a carbocation when it forms here, and also if we were to resonate this carbocation, what would form, here. So now that we did that, looks like at the other one, we'll write down all the products too, and then that'll answer question number 1, which is to provide all the 1,2, 1,4 products. So I'm going to write this back again. We have HBr. This attacks the bromine. This attacks the hydrogen. Apologies for my scratch chicken right, by the way. So what we'll get is this 1,2 carbocation intermediate. And this one is going to be a 1,2 secondary allylic, sorry. So this kind of already gives us a hint as far as what's going to be more stable. We have a tertiary allylic and a secondary allylic, but I'll get to that in a second. So now that I have my 1,2 carbocation intermediate, I'm going to form my product. So I have my negative bromine here, and it's going to attack this carbocation, and it's going to form my 1,2 product. So here's my 1,2 product, and like we said before, 1,2 product are almost always going to be the kinetic. So now let's look for the thermodynamic one. So what we can do is resonate this pi bond, and we're going to resonate it to move right here. So if I resonate that, we have this 1,4 carbocation. And now, just like before, I'm going to attack it with my bromine. And so this is going to be my 1,4 product. And this is going to be the thermodynamic. All right, so we've addressed question 1, right? We've provided all of the 1 and 2 and 1 and 4 products. So now let's look at question number 2, provide the resonance hybrid. So to provide the resonance hybrid, I'll just write it right here, resonance hybrid. I'm going to draw out all of the sigma bonds of the initial compound, and I'm going to write a dotted line for wherever the pi bond traveled through, and a partial positive for wherever there was a positive charge. So this is going to be the resonance hybrid for this compound when we react it with this double bond. And over here, is going to be this one. Here's the dotted lines everywhere where the pi bond is crossed. Here's my partial positives. So that answers question number 2. Provide the resonance hybrid for both structures. Now the last part, label the major and minor thermo and kinetic products. So when we have a question like this, as far as determining what's more stable in which reactant will actually which product will actually form, we want to look at the carbocation intermediates and see which one is more, which has higher priority, essentially. So we have a tertiary allylic versus a secondary allylic. So this right here is going to form my major products. So I now know that my 1,2 kinetic product is actually my major. I'll just kind of box it right here. Therefore, my 1,4 product of my thermodynamic will be the major as well. And because these are the major products, my latter are just going to be the minor. So this is the 1,2 kinetic product, and this is the minor. And this is the 1,4 product, the 1,4 thermodynamic product, and that is also going to be minor. So lastly, Oh wow, it's already 10 minutes. I'm rambling too much. General steps that kind of help me. First, I like to react with all the double bonds in the conjugated system. So that's what we did up here. We have the original compound, and I reacted it first with this double bond, and then I reacted it with this double bond. And then we wrote down all of the possible products right here. That would be step 2. We determined all of the 1, 2, and 1, 4 products, and that's what we did right here. And then we deduced that the 1, 2 product is kinetic. Before I gave the major and minor titles, we knew that this 1, 2 product is going to be kinetic, this 1, 2 product is going to be kinetic, this 1, 4 product is thermodynamic, and then this 1, 4 product is thermodynamic. Then step 3 is prioritize the carbocation intermediate to determine the greatest stability. So least stable would be primary, then secondary, then tertiary. And like we said, this is a tertiary allylic. This is a secondary allylic. So my tertiary allylic carbocation is going to produce the more stable products, which leads to step 4, the most stable, and I should write here, the most stable carbocation intermediate. The most stable carbocation intermediate is going to be the major product, and the latter is the minor. So like we said, tertiary, secondary. So therefore this is my major kinetic. This is going to be my major thermodynamic, which makes my latter my minor kinetic and my minor thermodynamic. I hope this helped.